12. We're looking at an exemplar. 2014 question paper, question 2, loci. It's cam. You are given the detail of a roller ended. It's a roller ended. The end it's a roller. It's a wheel. It's got a wheel here. Of a roller ended follower and a camshaft. This is the camshaft. This is your camshaft. The incomplete displacement of a graph. Displacement graph. This is a displacement graph which is incomplete. The position of S. Here is the position of S. On the answer sheet specification, the minimum distance from the cam profile. Minimum profile will start here. I think that will be the lowest point of the cam. So they say the minimum distance from the cam profile to the center of the camshaft. From this profile here to the center of the camshaft. The minimum distance, that distance is 19 millimeters. 19 millimeters. The follower reciprocates along 30 degrees center line which passes through the center of the camshaft. It reciprocates. To reciprocate, it moves up and down, up and down. It reciprocates at an angle of 30 degrees. Rotation is clockwise. The cam is rotating. The cam is rotating clockwise. The cam is rotating clockwise. We'll put an arrow. The instruction: draw to scale 1:1 the given follower and the camshaft. Let's draw the given follower. Here is a cam follower and the camshaft. Good. I'm drawing on a separate paper. I will start with my center lines. Center lines. Center line. Center line is a long short line. You must be able to draw center lines correctly. You have diameter 20 of the camshaft. Diameter 20, which is a radius of 10. Diameter 20 gives us a radius of 10. Diameter 20. Aha! What's happening? Elsewhere. Right. There is my 20 limited diameter. We will have that. That is my diameter. And then they said my cam follower is 30 degrees away. 30 degrees away. I use the set square to get to the center. To the center of my cam follower. My cam follower, that's the center of my cam follower. And then they told me that the minimum distance from the cam profile to the center of the camshaft is 19. I'll measure 19 here. Seeing is believing. You'll see what I'm saying. There is 19. My profile will start here. My cam profile will start there. That is the minimum distance. And then from there, that's when you will have now your minimum distance. It tells us your cam profile will be here, will start here. So from here, you have a 12 millimeter diameter. From that 12 millimeter diameter, you will draw the circle of the roller follower, which is radius 6. Radius 6 is gonna be here. These are small radii. Radius 6 is small radius. Make sure you've got the quality compass and you practice those. Here is my 6. My 6 will be here. There will be my 6, my center. Can tell you it's not easy to draw this small radii. As you can see, I'm also struggling. I am also struggling drawing that, but with practice you get better. Make sure you have your own utensils, your rubber. There is my, and then from that center there, you will have, let's do this, since that is 30, where am I now? To be 90, I must have that. Is at 90 degrees. If it is at 90 degrees, I have my center here of that, and then they told me that it must be, the follower is 65 units, 65 millimeters. 65 millimeters. I'll draw my 65 there. My 65 will be located here. 65 will be located, and the width thereof is 8. Width thereof is 8 millimeters. There is my 8. I'm not trying to undermine people by redrawing this. It is just through my experience that even just to redraw this stuff, to some other learners it is a serious challenge. It really is a serious challenge to just to redraw what we have there. 20 degrees. There we are. Remember, this needs to be perpendicular. That's 90 degrees. That forms 90 degrees. So I have redrawn. I have redrawn my cam follower. Now draw to scale to on the follower and the cam shaft. And the cam shaft, remember, it has been cut. The cam shaft has been cut. The cam shaft has been cut. Oh, that was the center line. The cam shaft has been cut so that you are able to see the cam profile. Cut the cam shaft. So it is at 30 degrees. Now I align it, make it to be straight. Align it there. From there I will move horizontally towards my profile. I'll move horizontally towards my profile. And now, instruction number 2, draw the horizontal scale of 8 millimeters equals to 30 degrees and a displacement scale of 1 millimeter equals to 1 millimeter. The complete displacement graph for the required motion. Label the graph. Now we are drawing the displacement graph. This is an incomplete displacement graph. Now we will complete that, but first we have to draw it. It means the spacing between these two lines is 8 millimeters. 8 millimeters. We will do that. 8 millimeters. Probably we will start somewhere around here, and then we'll make our 8 divisions, our 12 divisions of 8 millimeters. Now I'll take my compass there. I mark off 8 millimeters from my ruler. You don't need to have a special tool like what's a scale ruler. No, you can use this ruler. It's very effective and efficient here in EGD. 1, there must be 12, 2, 3, 4, 5, 6. I'll go on up to 12, but because for the sake of my camera, I just want to see the height of my displacement. I will look there. Here is the height of my displacement, will be 55 millimeters. So it will be displaced 55 millimeters, which means here I can measure 55 millimeters. Here I'll measure 55. There is my 55 millimeters. That 55 millimeters. This is what I will do. I know within this range. Why am I doing this? Is because I know my graph will be within this range, so that now I'm able to also utilize this space there to compensate for the size of my camera. So I don't have to move around my camera. So we have this 8 millimeters. And then I'm transferring that side. 1, 2, 3. Let's check now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 there. Yeah, I've almost managed, by grace of the Lord. I've managed to have everything confined within the scope of my camera. Here is this 55, it's somewhere here, it goes there, and then I make those divisions there. Encourage also other learners to do EGD, man. EGD is a nice subject. You exercise your brain muscles here. When you are tired doing your accounting, your maths, and so on and so forth, you simply do EGD just to refresh your memory. 0, 30, 60, 90, 120, 150, 180. Here we have 180. We have 180 degrees, 180, 210, 240, 270, 300, 330, and then the last one is 360. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The last one is 360. It's 360. I thought I won. You don't see the last one. The 361 there. I'll just lift my board so so that you see 360 degrees. From the question paper, it says here it is simple harmonic, smooth, it moves at P, simple harmonic. When we draw a simple harmonic from 55, you will divide the 55, into two equal parts, which is 55 divided by 2, that will give you 27 and a half. Let's verify that. 55 divided by 2 gives you 27 and a half. Now your center here will be 27 and a half. 25, 27 and a half. Our center will be somewhere there, which is 27 and a half. I'll just draw that center for me so that I'm able to see where is my center there. 27 and a half. Now, because we'll end at 360, I will draw an arc, but I don't want to interfere with my space here, where I'll be doing the profile. But here, from the displacement graph, I will draw an arc there. So where of 27 and a half. But I can also do it even on that side. I'll do it on that side. There we are. Do it on that side. And then you also divide that into 30-60 degree set with a 30-60 degree set square. Alright, where am I now? There. So up to 180. They say it is simple harmonic. Up to 180, it's a simple harmonic. My divisions, it is 1, 2, 3, 4, 5, 6 divisions. So even here I must have 6. Between 1 and 8, I will divide it into 6, irrespective of how many columns I have here. But fortunately enough, with this one it's easier. 1, 2, 3, 4, 5, 6. It's already been divided into 6. But sometimes it doesn't happen that way. You will have, maybe they say simple harmonic occurs only here for the first 30, 60, 90, 120 degrees. Then you'll have to divide it accordingly so that you have lines moving across the same number of lines. If there are 4 this way, we will have 4 also on that way. Now let's project it up to 100. This is from here to there, that, from here to there, that here from up to 180, because we're doing a simple harmonic. Yeah, it moves with simple harmonic movement from here. Now let's plot. It's gonna be 1, 2, 3, 1, 2, 3. Then we join freehand. That indicates a simple harmonic movement. We have something like that. And then from 180 to 360, it's uniform acceleration and the retardation. Uniform acceleration and retardation. We don't consider this now. Here it's a different story. What we do now, it's 1, 2, 3, 4, 5, 6. This is the midpoint of those. So I will divide this into 3 equal parts, and that one also into 3 equal parts. Are you with me? So which is 27 and a half. remember it's 55, so it's 27 and a half. 10.5 divide by 3 gives me 9.1. So 9.1 is almost 9 millimeters. 9.1, but it's 9.1. Right at 9 millimeters is 9.1. Then you will have 9.1. It's here, there, and there. So 1, 2, 3, 4, 5, 6. So it has been divided. And then I'll do that. Those lines. So as it moves back with uniform acceleration, retardation, what we do here, take a set square. We consider these two corners, this one and that one. Look what I am doing. From this corner, here is my midline. I will move from here to the first one, from here to the second one, from here to that 180 over there, that middle portion part. And then from the other end, from here is my center. I'll move to here. From there to there, it will be here. Right? Then, as we move from here, the first one will be here, second here, the third is this one, the fourth is that one, the fifth is this one, which will, when you join them, it looks like this. But it will look like there we have it in that fashion. Now, what this displacement graph will be translated now into forming a profile, a cam profile. So when you do that, we want to divide our circle also on this side into 12 equal parts. We use a 60-30 degree set square. There we are. That way, damaged my center. Made a big hole there. So there we are. Now, because my cam is here, it will be moving up and down as this shaft rotates. Since it will be rotating, it's 19. This minimum distance is 19. It is there. Tells us the minimum distance. And then they said it is a clockwise. It is rotating clockwise. Since it is rotating clockwise, here is an arrow indicating the direction of rotation. So it starts here. This will be our 0 degrees and 360 degrees. So as this is moving, this is what is moving. The cam follower is not moving. This is moving. So everything will come towards 0. From 0 there is 1 up to 30. Your 30 will be here. There is 1 up to 30. Your 30 will be here. 30 degrees will be here. That will be your 60 degrees. And then right here it is going to be your 180 degrees. Will be here. And then 1, 2, 3. Your 1, 2, 3. Your 270 is here. 300, 330, 360. Here is your 90 degrees. Now let's start. This is 0. It's moving towards that direction, and then we are transferring now 30, 60, 90. Let's do that. 30. This will be my 30, my 60, my 90. It's going up. 120, 150, 180 is at the top. So that will be my 0. I'll show you here. It was my 0. 0, it started there, is at 0. And then from 0 there is 30. 30 is here. From 30, 60 is here. 90 is there. 30. Oh, what's wrong? Okay, this is my 0. Start again. 0, 30. Oh yeah, I made a mistake. Here is my 0. And then there is my 30. My 30 is here. It is 30. And then this is my 30. This is my 30. This is that one. And then that is my 60. Is that one. My 60 is that one. So everything that is above there is not correct. Don't be afraid to use your ruler, your rubber. As long as you get it right and quickly and save time. This is my 60 there. This is my 90 there. That's my 90. That is my 120. It's here. That is what my 150 will be there. And then my 180 is right there at the bottom there of what we have there. Now from there you will be doing this radii, taking this radius and doing all those radii. You will notice it's not easy to draw a radius, a smaller radius. It is just not easy. It requires a lot of practice. So remember, this is not there. It just shows you that maybe at 90 degrees where your roller will be. Your roller will be located somewhere here. That is, your roller will be located somewhere here. Your roller will be located somewhere here. Right through up until 180. We have established that 180 will be here. Now, that is simple harmonic. It's moving smoothly up to there. Then from there, with uniform acceleration and retardation. So let's take those points now. From 180, it is 210. 210 is there. Let's transfer the other one now, the other side. 210. 210 will be here. That will be 210. Just to mark them differently, so that I know it's not for the first 180 degrees. The next one, 210, and then which will be 240 is here, and then 270 is also here. 300 will be here. 330 will be there. 360 will be right here where it started. Now let's start. It starts from the top. From the top, it will be that goes here, 210, and then lower it goes to 240. You lower it here, it goes to 270. Then you lower it here, goes to 300. And then you lower it here, it goes to 330 and back to 360. 330 is that one there. Now, same radii. Use the same radius. Oh yeah. You can see now the people who are not used to drawing that much, using those smaller radii, how much they struggle. The struggle, it is there, this one is there. Look at this one. I'm not making a full circle because what is important is that my profile will touch here tangentially. This is the part that is important. I'll show you after I've completed. Now, as I move, your hands should be steady. You must not focus only on one. Others may prefer to use a stencil, but it's okay when you use it also as a freehand. Use freehand, but do make sure that your hand touches the circle at one point. It must touch tangentially. It must touch tangentially. There. That is the same, that is the profile. This would be your profile. These are not important. They help you to draw this profile. Here, even if you made arcs here, just like I've done it here, this will be your profile. This is how the design will look like of your cam lobe, of your camshaft lobes. These lobes will look like this so that they give you this motion. And then let's continue with the question. What does it say? It show the direction of rotation, of which I've just done. Show all necessary construction. Draw the horizontal scale of 8 millimeters equals to that was given to us. You draw that displacement graph. You write there, it's a displacement graph. You write that it is a displacement graph. You write displacement graph. It is a displacement graph. Scale 8 millimeters. You write the scale. Oh, you write also. Okay, you don't see it there. You write scale 8 millimeters equals to 30 degrees. There we are. Then I think you have understood what we have just done here. Try it to do it on your own before referring back to this memo. Thank you for your time. See you in the next video. Thank you.